ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಕೊಡ್ಬೇಕು ಅಂತಿದ್ದೆ.
Good evening, sir.
Good evening. Good evening.
So, good evening, everybody. So, today's resource person, Dr. P. Nagaraju, sir. So, P. Nagaraju, sir, ಅವ್ರನ್ನ ನಾವು ಸ್ವಾಗತಿಸುತ್ತಾ ವೆಲ್ಕಮ್ ಟು
ಹಲೋ.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಹಲೋ.
ಕೇಳಿಸ್ತಾ ಇದೆ ಹೇಳಿ.
ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಡಾಕ್ಟರ್ ಪಿ ನಾಗರಾಜ್ ಅವರನ್ನ ಸ್ವಾಗತಿಸುತ್ತಾ ಹಾಗೂ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿ ಅಧ್ಯಕ್ಷರಾದಂತ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ ನಮ್ಮ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ ಹಾಗೂ ಹಾಜರಾಗಿರುವ ಎಲ್ಲ ನನ್ನ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳಿಗೂ ಕೂಡ ಸ್ವಾಗತ ಮಾಡುತ್ತಾ ಸೊ ನಾವು ಡಾಕ್ಟರ್ ಪಿ ನಾಗರಾಜ್ ಅವ್ರ ಬಗ್ಗೆ ಮತ್ತೇನು ಜಾಸ್ತಿ ಹೇಳಂಗಿಲ್ಲ. ಕಳೆದ ತರಗತಿಗಳಲ್ಲಿ ಅವ್ರ ಬಗ್ಗೆ ಅವರ ಪರಿಚಯಗಳನ್ನ ಮಾಡ್ಕೊಟ್ಟಿದ್ವಿ. ಸೊ ಈಗ ನೇರವಾಗಿ ಸರ್, ಓವರ್ ಟು ಯು ಸರ್.
Okay, thank you, sir. Thank you for the introduction.
Okay,
I think I will start now. Okay, dear students, I wish you all the best and good afternoon to everyone here. And today I am going to take up on the mechanical properties of fluids. I think you know the properties, the word meaning of mechanical properties and fluids. First thing is, what do we mean by a fluid? Fluid means it may be a gas or a liquid. So a common word fluid is used for the gas as well as for the liquid. And when we have a liquid in any container, naturally it offers the pressure. And therefore, we have to understand some basic definitions with respect to the mechanical properties of fluids. The first thing is pressure. What do we mean by a pressure? It is the normal force exerted by a fluid at rest on a surface in contact with it is called fluid thrust. So thrust is nothing but the force, and thrust per unit area is called the pressure. But in general, we define the pressure as P is equal to F by A, that is the force by area. And you know, force is in Newton and area is measured in meter square. And therefore, here I have given that pressure is, instead of saying that force by area, here with respect to the fluid, we write it as thrust by area. And how about the unit of pressure? I have already told you that pressure is nothing but the force by area. Force is measured in Newton and the area is measured in meter square, and therefore the unit of pressure is Newton per meter square, or we can even write it as Newton meter minus 2. And that is also 1 meter minus 2 is in other words called Pascal. And symbol used is PA. That's what you can see there on the screen. And pressure at a point in a liquid due to a liquid column. A liquid column in the sense, suppose you take the liquid in a container, naturally you will have a sort of a column. And suppose the column of height is h or a depth h from the free surface of the liquid, which is given by P is equal to rho g h. Maybe here I have used capital P, but for pressure, it is to be denoted by small p. And because just I have used here by mistake P, don't think that the pressure is to be denoted by capital P. It is actually denoted by small p, and power is denoted by capital P. And P, the pressure is equal to rho g h, where rho is the density of the fluid, in other words, the liquid. G is the acceleration due to gravity, and h is the height or the depth. Suppose we talk from the bottom, we write it as height. And suppose we take from the free surface of the liquid, that is from the top, we call it as depth. And you know already the unit of density, it is kg per meter cube. And the acceleration due to gravity, it is meter per second square. And height is measured in meter. They are all in SI. And now let comes to atmospheric pressure. Yes, the atmospheric pressure is measured by a unit, and that is again same as this. We write it as 1 atmosphere. And you know that it is measured by an instrument called the barometer. And remember, the temperature is measured by an instrument called the thermometer, and the pressure is measured by an instrument called the barometer. In fact, usually in a laboratory, both the barometer and the thermometer will be fixed side by side. And barometer is quite a long rectangular box, whereas thermometer, you know, usually either the alcohol thermometer or the mercury thermometer. And in most of the colleges, mercury thermometer is used rather than the alcohol thermometer. And now, of course, we may go for digital thermometer. And this atmospheric pressure was actually established by Torricelli. And therefore, in the name of Torricelli, we also use the unit called torr. And that is expressed in terms of millimeter of mercury. And here I have given like 1 atmospheric pressure is equal to 1 atm equals 1.013 into 10 raised to 5 Newton per meter square. Or we can write it as 1.013 bars. And 1 bar is of the order of 10 raised to 5 Pascal. And how do we calculate? You know, as far as the measurement of pressure, we use the barometer, and there we use the mercury column. We don't go for water, because you know the density of water is only about 1000, whereas the density of mercury is 13,600 kg per meter cube. And if I use the formula P is equal to rho GH, you can substitute it there. It is 13,600 into 9.8 into 0.76. That means 76 centimeter or 0.76 what we can write here. And on simplification, you get this value. So now coming to the Pascal's law. What is this? This is, in other words, called the principle of transmission of fluid pressure. It states that when pressure is applied to any part of the surface of the liquid, an equal and uniform pressure is transmitted over the whole liquid. So, what do you understand from this? It is only the transmission of pressure. So, an equal and uniform pressure is transmitted over the whole liquid. In the sense, suppose you take a liquid in some container, maybe some irregular shape. You may apply some sort of force on one side, and naturally the pressure, you can see that on the other side also. That is why we say that it is the principle of transmission of fluid pressure. So an important application of this principle is actually in hydraulic press. Anyway, I'm not going to discuss that. That itself will take time. That's why I avoid it. And of course, it is already given there. You can just go through it. And coming to the Archimedes principle, this is very, very important for us, because we normally have at least 2-3 problems on Archimedes principle. What is this Archimedes principle? The statement is, when a body is completely or partially immersed in a liquid, it appears to lose a part of its weight, and the apparent loss of weight is equal to the weight of the liquid displaced by the body. So, when once a body is either completely or partially immersed in a liquid, it appears to lose it. Yeah, that's what you know. For example, when you take a small stone and weigh it in air and then put it in water, you see that when once it is placed inside water, it appears as though that it loses some weight. That apparent loss of weight is actually equal to the weight of the liquid displaced by the body. That means when you take a stone, you don't have to go to the laboratory to conduct this experiment. You can take some glass and then you can take some stone. If it is a regular one, better. Otherwise, also no problem. When once you tie that stone by means of a thread and put it in a beaker in the sense glass of water, you see that the water level rises, and that means the apparent loss of its weight is actually equal to the weight of the liquid displaced by it. So when a body is completely or partially immersed in liquid, it experiences an upthrust. That means the liquid is actually exerting its pressure on that, or the force on that stone or on that object which is immersed in a liquid, which is equal to the weight of the liquid displaced. Suppose you take that liquid and find out its weight, you see that what the weight loss is equal to the weight of the liquid displaced. Thus, the apparent weight of the body is equal to true weight minus upthrust. So what do we mean by this true weight? The true weight is nothing but the weight of that body in air. And upthrust, if you measure it or if you find out the weight in any liquid, not necessarily water, any liquid you can take, but usually the water we take because it is easily available to us rather than any other liquid. And thus, a body weighs less when immersed in a liquid. So the upthrust is called, in other words, called the buoyancy. It is called, let a body of volume V and density rho be completely immersed in a liquid. Yeah, in order to find out, we are taking the volume of the liquid and density completely immersed in liquid of density rho dash. The true weight of the body, we can write it as, that's what I told you, the apparent weight is actually equal to the true weight minus the apparent, what is that, upthrust. So then true weight of the body is W is equal to mg. And you know the mass is, density is nothing but mass by volume. And therefore mass can be written as V into rho, that is volume into density. And for a weight, actually it is to be multiplied by g, that is the acceleration due to gravity. And therefore we write it as V rho g. And upthrust is weight of the liquid displaced. And to find out the weight of the liquid displaced, we use that volume, whatever the volume displaced by it, and the density, that you can call it as rho dash, and g the acceleration due to gravity. Therefore, the apparent weight of the body is Wa. Here I have used the A subscript. Wa is equal to V into rho g, and that is nothing but V rho g minus V rho dash g, and V is common here, and that is why we write it as rho minus rho dash g. And in other words, we can even take that rho g outside, and therefore we can write it as 1 minus rho dash by rho. And these are the conditions. If rho greater than rho dash, that means the density of the solid material is greater than the density of the fluid, and that is W greater than 0. That means body will sink. That means if the density of the solid body is greater than the density of the liquid, it will go down. That is what we write it as, body will sink. And if on the other hand, if rho dash is greater than rho, that means the density of the liquid is greater than the density of the material. Or in other words, you can also write it as, if rho is less than rho dash and Wa is less than 0, the body will move upwards. That means if the density of the fluid, or in other words, the liquid, is greater than the density of the solid material which you are immersing it, then it will go up because of the upward thrust and floats. On the other hand, if rho is equal to rho dash, that means Wa is equal to 0 body is just floats. That means it is neither going up or neither not coming down. It will be floating just on the surface of the liquid if rho is equal to rho dash. So what are the examples for these three conditions which I have given here? The first one is floating of a ship. You know the float ships. The ship is floating, and even when we are swimming, we will be on the surface of the water, and even submarine. All these are examples for the three conditions which we have discussed just now. And now let me come to what is called an ideal fluid. What we have discussed so far is only a real fluid. And suppose we think of an ideal fluid, the fluid which is non-viscous and incompressible. So you know that the air is compressible, whereas any solid material is incompressible. Like that, if the liquid is incompressible, that means if you apply the pressure on it, if it doesn't shrink, then what we call it as the incompressible, and which is non-viscous. Yeah, when we discuss about the viscosity, we will understand more about the viscous force, or in other words, we also call it as the opposing force. Yes, let us now understand something about the streamline flow, or in other words, we may call it a streamline motion. So when we have a fluid, or in other words, the liquid, these are the conditions for streamline flow. What is that? Every particle of the fluid follows the path of its preceding particle. That means what the particle is moving ahead, it follows the same path as the previous one. That means the particles which are moving ahead and the particles follow the other particles will be in the same path, and flow is steady. Steady in the sense it is almost like a constant velocity. In other words, there is no change in velocity with respect to time. And if you draw a tangent to the streamline at any point, it gives the direction of the fluid at that point. And it may be straight or curved. Normally, in respect of streamline flow, we may say straight, and it could be even curved also. But even if it is curved, it doesn't mean that it has to come back. It may be of having the curve shape, and that is why the tangent drawn to the streamline at any point gives the direction of the fluid. That means even in the curved shape, it should not suddenly change its curvature. So amount of fluid entering any body, maybe you can think of a tube, is equal to the amount of fluid leaving in 1 second. So whatever the amount of fluid which is coming into the tube must be equal to the amount of fluid going out or leaving in 1 second. There is no radial flow and no streamlines interact. That means one streamline will not interact with the other. That's why we say that in shortest term, no two streamlines interact. Velocity remains the same throughout. That's what I told you. There is no question of changing its velocity with respect to time. That is why we also call it as flow is steady. And in other words, the velocity remains the same. Then what we have here is the turbulent flow. What do we mean by a turbulent motion or turbulent flow? If the velocity is constant, then you call it as the streamline flow. But on the other hand, if the velocity exceeds a certain limit, and then that flow loses the orderliness, and such a flow is called a turbulent flow. And I don't know whether you have seen in some river or in some times sea, if there is some rock in the path of the water which is coming, it hits the rock. And if the rock is appear to us from a distance, you can see that the river, the water in a river hits the rock and goes back. That is, in other words, it changes its path. No question of something like streamline flow. There is no question of changing the path. See, what you have got, the first sentence is every particle of the fluid follows the path of its preceding particle. But here, the path of after it hits the rock or any other object, it changes its path. And that is why orderliness is altered. Flow is, that motion is another word called turbulent flow or turbulent motion. And paths of the particles of the flow change continuously and it will be irregular. Yeah, that's what I told you. The water which is coming and hitting the rock or any other object which is there will go back. Sometimes even if you are going in a boat, you can see that the water, if the what is that, the speed of the water is more, it will hit the boat at the bottom and then goes back. And that only if you observe it carefully, you can see that. And further, velocity of the fluid at a point is not same and change with the time. And this is what we have on. Further, a portion of a liquid may acquire a rotatory motion. That's what I have already told you, that when water is coming and hitting rock in the river, then it goes back, it forms some sort of a circular motion. In other words, called the rotatory motion, and that is also called eddies or vortices. So the turbulent motion, in other words, we call it as eddies or vortices, which we cannot see or observe in the case of a streamline flow. And thus, the streamline flow and the turbulent flow can be taken or understood with the help of a non-dimensional number. That non-dimensional number is called Reynolds number. And the Reynolds number is denoted by Re, which is equal to rho Vd by eta, where rho is the density, V is the velocity. That velocity you can either V or U, you can use any symbol of your choice. And D is the depth or width or whatever you call it. And eta is the coefficient of viscosity. Suppose Reynolds number Re is less than 2000, we normally say streamline. And on the other hand, if it greater than 3000, it leads to turbulent flow. So again, it depends on the situation, but maximum number it is given here, it is less than 2000 and greater than 3000. Then let us now come to the equation of continuity. So what is the equation of continuity? Continuity equation, in other words, called, we write it as A1 V1 is equal to A2 V2, which is nothing but the area, and V1 is the velocity. Suppose the area is more, the velocity is less. And on the other hand, if the area is less, the velocity is more. Yeah, that is what you can see in sort of a pipe. Let us say at the center, it may be somewhat less size, or the depth is less. Suppose the depth, or what you call it as the diameter, is less in between. And in such a case, in between, the velocity will be more. So this is what we have on the equation of continuity. And whenever the water or any liquid is flowing, naturally we can have different forms of energy, which we write it as pressure energy, kinetic energy, and potential energy. What is that pressure energy per unit volume? It is denoted by the symbol P. And kinetic energy per unit volume is denoted by half rho V square. It is per unit volume. Instead of writing half mv square, here we write it as half rho V square because it is per unit volume. Similarly, the potential energy per unit volume is written as rho gh. Rho is the density, g is the acceleration due to gravity, and h is the height. The statement of Bernoulli's theorem, what you have got there, you can put it in a different way. It is only for an ideal fluid. I told you for an ideal fluid, it is non-viscous, and the other property, what you have already got it for an ideal fluid, already it is mentioned. And the sum of the pressure energy, kinetic energy, and potential energy per unit volume remains constant. That means here the sum of all the three energies. What are the three energies we have? Pressure energy, kinetic energy, and potential energy per unit volume remains a constant, which we can write it as P plus half rho V square plus half rho GH. It is a constant. That means here, for horizontal flow of liquid, the liquid may be flowing at a certain height. So as long as the height is same with respect to the ground or with respect to the level of measurement, H is constant. In such a case, we write it as rho, the density of the liquid is constant, G, the acceleration due to gravity is constant. But here we have to think that the acceleration due to gravity remains the same. And you should not get confused with what you have studied in gravitation chapter. Under the gravitation chapter, you also study about the variation of acceleration due to gravity, due to height and due to depth. But here, the acceleration due to gravity is taken as 9.8 and it is constant. It doesn't mean that the liquid is flowing at certain 36,000 kilometer or something like that. It may be at a height of some even, let us say, 10 meter. Even in this case, the acceleration due to gravity is taken as constant. Thus, if rho gh is constant, we write it as P plus half rho V square is equal to a constant. And what are the applications of the Bernoulli's theorem? There are several applications, but I am mentioning only a few applications here, which we thought of. Atomizer. What is that atomizer principle? In other words, you know, we are using what is that called paint. And you know, the paint when we are using it, will, in other words, called the sprayer. Even in a garden, the sprayer is used. It works on the principle of atomizer. Yeah, actually, and even nowadays it is very common, the principle of the atomizer, because of the COVID. Whenever you go to a shop or even in your house itself, you may be having, if you just press the top, the liquid will come out in the form of fine droplets. And that is actually because of the pressure variation at the bottom as well as at the top. And this is what we call it the atomizer. Uplift of an aircraft, you know that the pressure at the lower wing is slightly greater than the pressure at the upper surface of the wing, and therefore it goes up. And then also we have the same principle in a carburetor, which we are using in a vehicle, and also venturimeter. This is an instrument which we actually measure the volume of water which is flowing. And with this, instead of going to the viscosity and the surface tension, we will come across, because the organizers have also told me to take up some few questions with respect to the CET, NEET or JE, whatever you call it. Usually in any, yeah, I am now discussing a few multiple choice questions. I may not be able to take, at least I thought of taking some 10 questions. Here, usually whenever a question paper is prepared, some criteria is followed. Let me just tell you, first one is what we call it as K, and that you can also call it as A1, that is nothing but knowledge. So based on what you know or what you have understood, that you can apply, that is knowledge based question, which we can also call it as easy question. That means the moment you look at the question, you will be able to get the answer. The next, which you can write it as KC, that is comprehension, knowledge plus some little bit difficult one, that you call it as A2, comprehension. KCA, application. That means whatever you have studied, which you have to apply. Yes, when I take up some problems on that, you will understand which one is the knowledge base, which one is comprehension, and which is the application. Then further, we also have what is called KCAAN. That is, in other words, you may call it as A4, which is nothing but analysis. That means you have to analyze before you get the answer. You can take that. ನಿಮ್ಗೇನೆ? ಏನು ಪರವಾಗಿಲ್ಲ ತಗೊಳ್ಳಿ. Okay. That is what we write it as A4, in other words, called analysis. And further also we have KCAAS. In other words, it is called A5, and that A5 is nothing but synthesis. That means you have to apply all those things and get the solution for the problem. And the last one, evaluation. That means how you have evaluated. I am actually, instead of going to 6 parts, I will be telling you about 4 parts. like easy question, then medium type, and difficult, then again about complicated problem. So let me just think of the first question. What is the first question? The first question says along a streamline. Just now I have explained what the streamline flow is. Where the streamline, the forward particle follows the preceding particle. That means there is no sudden variation in velocity. The velocity remains the same. Some 8 properties of the liquid flow, in other words, streamline flow, we have discussed, and one of them should be here. What is that? In fact, if you just read, especially in these type of questions, you have to read all of them. Sometimes the last one may be the correct answer, because you may feel that the first one is correct, second one is correct, third one is also right, and even the fourth one. But anyway, in this case, when you read it, the velocity of all fluid particles at a given instant is constant. This is the same definition which I have explained with respect to streamline flow. But let us see the other one. The velocity of a fluid particle remains constant. The velocity of a fluid particle remains constant. The velocity of all fluid particles crossing a given position is constant. And the last one we can say, the speed of a fluid particle remains constant. Among all these things, which one is the most suitable question? And the velocity of all fluid particles. What you have, the velocity of a fluid particle remain. It doesn't mean that only one particle remains constant or crossing a given position. The speed of a fluid particle. Yeah, the other choices, what you see that they are referring to one, but only the first choice says that the velocity of all fluid particles at a given instant is constant. And that is why the first option, and of course, this is the easiest one. And this, in other words, also called knowledge-based question. Because what you have studied or what you have understood from the properties, we are just applying that. And coming to the next question, this question is also very, very simple. The second question is, iceberg floats in water with part of it submerged. The fraction of the volume of iceberg submerged is, density of ice is given as 917 kg per meter cube. Either you can write it as kg meter minus 3 or kg per meter cube. It may be given in whatever way it is. It depends on the paper. So either it can be written as kg meter minus 3 or kg per meter cube. So you have the choices like 1000, 0.917, 917, 1 like this. And what you have to write, that the question says the fraction of the volume of iceberg submerged. If you call it as x, submerged portion is nothing but x, then you have to divide the density of iceberg with respect to density of water. The density of iceberg, which is given as 917, and the density of water, anyway, it is not given here. Even though it is not given, you should take it as 1000. That means 917 divided by 1000 gives you 0.97. Therefore, the correct option for this is 0.917. And even this is also a correct answer, in the sense the part B is correct. So 0.917. And coming to the third question, and third question appears to be little, not I should say tough, but of course it is quite lengthy. And you cannot expect that all the time you should have only one line question, two line questions. It may be running for some 3-4 lines. Yeah, it doesn't mean that when the question runs for 2 to 3 lines, the question will be complicated. The question may be simple, but the sentences may be there. And for example, when we read this, water is flowing through 2 horizontal pipes of different diameters which are connected together. So there are 2 pipes but they have different diameters and they are connected together. The diameter of the two pipes are 30 mm. So it is given in millimeter, and the other one is 60 mm respectively. If the speed of water in the narrow tube is 4 meter per second, so that means among the two horizontal pipes, one is of narrow and the other one is quite bigger. What is that? In a narrow tube, it is 4 meter per second and the pressure is 2 into 10 raised to 4 Newton per meter square. Then the speed of water in the wider tube is how to? Yes, of course, you can go for the continuity equation. What that continuity equation says, maybe if you have your pen and paper, you can write down according to equation of continuity. A1 V1 is equal to A2 V2. No doubt here you have to calculate. You don't get it just by looking at it. And suppose you feel that you are going to, what is that called, guessing, then the guessing may be bit we may go wrong. That's why you have to work it out. Of course, you know, almost 1 minute per question. But there are some questions like what I have told you about the first and the second question. They hardly require about 30 to 40 seconds because even the length of the question is very, very short. It doesn't take more than 10 seconds to read it. And coming to this question, of course, it may take 15 to 20 seconds to read and other 20 to 30 seconds. So within 50 seconds itself, you would be able to work out this. So that's why if you have the pen and the paper, yeah, you just write A1 V1 is equal to A2 V2. And then you write V2 is equal to, that is what we want to find out, the velocity in the wider tube. That is A1 V1 over A2. But what is the area? Remember, it is circular tube. Horizontal diameters are given, and you have to write the area of cross section. The area of cross section is nothing but pi r square. But for A1, we write it as pi r1 square V1, and for A2, we write it as pi r2 square. And further, pi cancels. You have V2 is equal to R1 by R2 square V1, and V2, what is that? R1 by R2 square V1. Already it is given. What is that? 30 mm, 60 mm. You can just write 30 by 60 becomes 1 by 2. So you can write it as 1 by 2 whole square, and 1 by 2 whole square is nothing but 1 by 4, and into 4 is nothing but 1. Therefore, the answer is 1 meter per second. Third option is correct option. And this is what we call it as a medium, and medium means it is the application. Application in the sense we have to apply whatever the formula we know. And nothing like we are analyzing. We are only applying the formula what we know. That is A1 V1 is equal to A2 V2. And therefore, this type of problem we call it as a medium question. So coming to the fourth one, what is that? I think here it is slightly altered because I have used in a word. The D has gone below. Anyway, whatever may be the case, you can understand the question. Here, two mercury droplets of radii 0.1 centimeter and 0.2 centimeter collapse into one single drop. The amount of energy released, approximately, the surface tension of mercury is taken as 0.435. So what is that we have to do in this case? Here two mercury droplets, no doubt it is given in what centimeter, and invariably you have to convert that into meter because the answer is given in joule, and therefore you cannot take 0.1 centimeter and 0.2 centimeter as it is. You have to convert that. Maybe 0.1 centimeter you can write it as 0.1 into 10 raised to minus 2 because you know 100 centimeter or 10 raised to 2 centimeter is 1 meter, or 1 centimeter is 10 raised to minus 2 meter. 0.1 into 10 raised to minus 2, which you can write it as 1 into 10 raised to minus 3. Similarly, the other one is 2 into 10 raised to minus 3. Collapse into one single drop. And what you have to, yes, it is, I don't say it is very, very tough, but it requires some calculation, and therefore it is a question of analysis. That is, you may call it as, somewhat difficult. I don't say that it is very difficult, but somewhat difficult. If you have again the pen and the paper, you have to take volume of two droplets is equal to volume of single drop. And volume of one drop is 4 by 3 pi r1 cube. We assume that they are droplets which are spherical in shape. And therefore, 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube equals 4 by 3 pi r cube, capital R cube. That is actually the radius of the single large drop. So further, anyway, 4 by 3, 4 by 3, you can cancel it in the left hand side as well as in the right hand side. You have R cube is equal to R1 cube plus R2 cube. And I told you already, you can take it as 10 raised to minus 3 whole cube plus 2 into 10 raised to minus 3 whole cube, which you can write it as almost equal to 1 plus 8, 2 cube into 10 raised to minus 9. And further also you have to simplify what is the radius of the bigger one. That you can write it as R, capital R equals. It is 8 plus 1 or 1 plus 8 is 9. 9 to the power of 1 by 3. Similarly, 10 raised to minus 9 becomes 10 raised to minus 3. And therefore, what you have 9 to the power of cube root of 9, which is almost equal to 2.1. Approximately you can take. That is why even in the question it says approximately. And further, decrease in surface area you have to find out. And that is nothing but 4 pi r square, capital R square, minus R1 square plus R2 square. And on simplification, you get 10 raised to minus 6. And further, what you can, I just tell you, better you note down that. And therefore, it comes to be about minus, you are getting minus, and that is 7.4 into 10 raised to minus 6. And therefore, the energy released is nothing but the surface tension into decrease in surface area. And surface tension is nothing but it is given already 0.435. Sometimes it may be given as 43.5 into 10 raised to minus 2 or 435 into 10 raised to minus 3. Let it be given in whatever form they like. But anyway, you should be able to substitute it. And on simplification, you get minus 3.2 into 10 raised to minus 6 joule. That's what. One thing is you have to convert from centimeter to meter. Only then, anyway, the surface tension, fortunately, it is given in Newton per meter. And surface tension, I told you we will take it up later. But surface tension is nothing but the force per unit area, per unit length of an imaginary line on the surface of the liquid. And that is why the unit of surface tension is Newton per meter. It is the force acting on an imaginary line on the surface of the liquid, and that is why we write it as Newton per meter. Therefore, the correct answer on simplification, you get it as like this. Then if we go to question number 5, it says the question number 5 is somewhat, I may say even it is a medium question. Of course, yeah, this based on viscosity. I didn't talk about the viscosity, but anyway, water, you will study that as capillary rise. Based on that, it is given. So it is 16.3 centimeter. It is given in centimeter. Capillary tube of height 18 centimeter above the water level. If the tube is cut at a height of 12 centimeter. And remember here, based on RH is constant. That means if the radius is big, then the height through which the liquid rises is small. And that is why we use capillary tube. On the other hand, suppose you take any glass tube of bigger diameter, you don't find the rise in the level of water inside. Yes, the reason for that is about the cohesive force, then adhesive force, all those we discuss. Anyway, we can discuss it later. But here, if you read all the choices, water will flow downside the capillary tube, the height of water will come out as, yes, water will stay at a height because it is a height 16.3 centimeter, capillary tube height 18 centimeter, but it is cut at a height means 6 centimeter is cut, and therefore it will stay up to 1 centimeter, it will not come out. So this is what you have on question number 5. We will come to question number 6. The question number 6 is again a medium type, and that medium is again an application type. That is pressure inside two soap bubbles are 1.01 and 1.02 atmospheres. Ratio between their volumes is, of course, here, even though I have typed it properly, and only, when we convert that into PDF, it remains intact. Otherwise, it keeps changing like this. So anyway, you don't have to bother, but here you find all the choices, and the choice for this one, question number 6. The question number 6 is, again, you have to write, for example, you have to work out, and excess pressure inside the first bubble, you have to take it as 1.010 minus 1, and that you can write it as 0.01 atmosphere. And the second one is 1.02 minus 1, that is nothing but 0.02 atmosphere. And remember, the pressure is P is equal to 4T by R1. Of course, this relation also to be discussed. And the other one is for T2 by R2. We write it as P1 by P2 is equal to 4T over R1 whole over 4T by R2 and R2 by R1. And again, you have to take volume V1 by V2, 4 by 3 pi R1 cube, 4 by 3 pi R. And if you simplify that, you get 8:1. So B is the answer for that. And in question 7, in a vessel of water, a hole is made, that is what, at a depth, what is that? 4.9 meter from the free surface. Then the velocity of efflux. Yeah, you remember the formula, velocity of efflux is V is equal to square root of 2gh. You just substitute. Yeah, this is also a medium type, and medium means again you have to apply the application or apply the formula. You will get it, and this becomes what you have, velocity of efflux is V is equal to square root of 2gh, 2 into 9.8 into 4.9, because it's given that depth is 4.9, and 2 into 4.9 is 9.8. You have under the square root 9.8 into 9.8. Therefore, the answer must be equal to 9.8, and the correct choice is 9.8. Similarly, if I go to question number 8, that question number 8 is, a body floats with 1/3 of its volume outside water and 3/4 of its volume outside another liquid. The density of another liquid in kg per meter cube. So what you have to remember here, weight of water, what you have got is displaced, that you can write it as 2 by 3 V rho g, and the other one is 3 by 4 means it becomes 1 by 3. So floats with 1 by 3 means remaining is 2 by 3 here. And here it is 3 by 4 means remaining is 1 by 4. You equate the two, that is 2 by 3 V rho g is equal to 1 by 4 V rho dash g, and rho dash is nothing but 8 by 3 rho. Rho is 1000, and thus you get the first option, that is 8000 by 3. So coming to question number 9, the question number 9 is, an iceberg is floating, partly immersed. This is, I don't say complicated, but somewhat like that. An iceberg is floating, partly immersed in seawater. the density of seawater is 1030 kg per meter cube and the ice is 920 kg per meter cube. The fraction of the total volume of the iceberg above the level of seawater in percentage. So if you take the percentage calculation, so that question, of course, weight of water displaced, you remember the formula like that, equals weight of iceberg. Weight of water displaced, you can write it as capital V minus small v into density rho, that is 1030 G equals V, that is the weight of the iceberg, V into 920 G. And simplify that, and on simplification, you will get it as 11%. And thus, we go to question number 10. The question number 10 says that an inflated balloon rises to a certain height and another rise and cannot rise any further. This is because you see that as we go up or as we go to higher, the density of air decreases, and at a certain height, the weight of the air displaced is equal to weight of the balloon, and therefore it will stop. It cannot go further. So like this, we have other questions, and I have discussed only about 10 questions. Remaining questions are also there. I have given here up to almost 25 questions, and here it is changed. I will convert that into PDF and submit it to the KSC office. Then you can take it, because in question number some formula are there, and you see that the formula are actually changed like this. It is not. Anyway, so I think it is already the time up. If you have any questions, you can ask me now. Yes, sir. I am through.
Sir, Nagaraju sir.
I hear you, sir.
Sir, if you don't mind, you send 2 questions through WhatsApp, sir, for me.
ಆಯ್ತು ಆಯ್ತು ಕೊಡ್ತೀನಿ.
ಯಾಕೆಂತಂದ್ರೆ ಈಗ ಮುಗಿತಾ ಇದೆ, ಅವ್ರಿಗೆ ಎಂಡ್ ಆಫ್ ದಿ ಸೆಷನ್ ಸೆಂಡ್ ಥ್ರೂ ಟ್ಯಾಲೆಂಟ್ ಸರ್ಚ್ ಗ್ರೂಪ್
ಈಗ ನಾನು ಆಬ್ಜೆಕ್ಟಿವ್ ಟೈಪ್ ಕ್ವಶನ್ ಕೊಡ್ಲಾ, ಎಲ್ಲ ಎಸ್ಸೆ ಟೈಪ್ ಕ್ವಶನ್ಸ್ ಕೊಡ್ಲಾ?
2 descriptive type questions on today's topic, sir.
ಎಸ್, ಒಂದೆರಡು ಇದನ್ನು ಕೊಡ್ಲಾ ಆಬ್ಜೆಕ್ಟಿವ್ ಟೈಪ್?
ಇಲ್ಲ ಬೇಡಿ ಸರ್, ಇದ್ರದ್ದು ಏನ್ ಬೇಡಿ, ಜಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ 2 descriptive type questions.
ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್ ಕ್ವಶನ್ ಕಳಿಸ್ಕೊಡ್ತೀನಿ. ಡೆಫಿನೆಟ್ಲಿ. I think now I am on time. I didn't exceed like earlier days.
Okay, sir. I share this 25 questions to all the students through WhatsApp group.
ನಾನು ಅದನ್ನ ಒಂದು ಸ್ವಲ್ಪ PDF ಮಾಡಿ, ಈಗ ಇಫ್ ಯು ಲುಕ್ ಅಟ್ ಕ್ವಶನ್ ನಂಬರ್ 16 ಅಲ್ಲೊಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಆ ಫಾರ್ಮುಲಾಗಳೆಲ್ಲ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗಿದೆ ಇದು ವರ್ಡಲ್ಲೇ ಇರೋದ್ರಿಂದ. ಯಾಕೆಂದ್ರೆ ನಾನು ವರ್ಡಲ್ಲಿ ಮಾಡಿ ಮೇಲಲ್ಲಿ ಹಾಕೊಂಡಿದ್ದೀನಲ್ವಾ, ಸೊ ಅದಕ್ಕೆ ಹೀಗಾಗಿದೆ. ಸೊ ಅದನ್ನ ಬೇಕಾದ್ರೆ ನಾನು PDF ಮಾಡಿ ಕಳಿಸ್ಕೊಡ್ತೀನಿ.
ಈಗ ನನಗೆ ಸರ್, ಈಗ ನೀವು ಕಳಿಸಿದ್ರೆ ಒಂದೆರಡು 3 ನಿಮಿಷದಲ್ಲಿ ನನಗೆ ಅದು ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್ ಕಳಿಸಿದ್ರೆ ನಾನು ಶೇರ್ ಮಾಡ್ತೀನಿ ಸರ್ ಇವಾಗ ಮಕ್ಕಳಿಗೆ.
ಹೌದಾ? ನೀವು ಅದನ್ನ PDF ಮಾಡ್ಕೊಳ್ಳ. ಸಾರಿ, ನಿಮಗೆ ಬಂದಿರೋದು ಹೀಗೆ ಇದೆ.
ಎಸ್ ಸರ್,
ನೋಡ್ತೀನಿ. ಆಯ್ತು.
ಅಲ್ಲ, ನನಗೆ ಇದ್ರದ್ದೇನು ತೊಂದರೆ ಸರ್. ಈಗ ನನಗೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಹಾಕ್ತಾ ಇದ್ದೀನಿ ಹುಡುಗರಿಗೆ. ಸೊ ತೊಂದರೆ ಇಲ್ಲ.
ಓಕೆ ಸರಿ, ಗೊತ್ತಾಗುತ್ತೆ ಅವ್ರಿಗೆ ಓದಿರೋದ್ರಿಂದ ಹೇಗೆ ಯಾವ ತರ ಶಿಫ್ಟ್ ಆಗಿದೆ ಅಂತ. ಓಕೆ, ಎರಡು ಕ್ವಶನ್ ನಿಮಗೆ ಕಳಿಸ್ಕೊಡ್ತೀನಿ ಆಮೇಲೆ.
ಸರಿ.
ಸೊ ಮತ್ತೆ ಯಾರಾದ್ರದ್ದು ಇದೆಯಾ ಕ್ವೈರೀಸು?
ಸರ್ ಒಂದ್ ನಿಮಿಷ ಸರ್. Dear students, please ask any questions or any doubts on today's topic. ಏನೇ ಕ್ವಶನ್ಸ್ ಮತ್ತೆ ಡೌಟ್ಸ್ ಗಳಿದ್ರು ಕೇಳಿ. ಸೊ ಯಾವುದೇ ಕ್ವಶನ್ಸ್ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲೂ ಇಲ್ಲ ಸರ್, ಹುಡುಗರು ಕೇಳ್ತಾ ಇಲ್ಲ.
ಹೌದಾ? ಸೊ
ನಾನು ಲೇಟರ್ ಆನ್ ಐ ಸೆಂಡ್ ಥ್ರೂ ಮೇಲ್ ಸರ್. ನಿಮ್ಗೆ ಏನಾದ್ರು ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಮೇಲ್.
ಓಕೆ, ಖಂಡಿತ ಕಳಿಸ್ಕೊಡಿ.
ಸೊ ನನಗೀಗ ಎಂಡ್ ಆಫ್ ದಿ ಸೆಷನ್ ನನಗೆ ಅದೊಂದೆರಡು ಕ್ವಶನ್ಸ್ ಕಳಿಸ್ಕೊಟ್ರೆ ಸರ್, ನಾನು ಸ್ಟೂಡೆಂಟ್ಸ್ ಗಳನ್ನ ಕಳಿಸ್ಕೊಡ್ತೀನಿ ಸರ್.
ಸರಿ, ಕಳಿಸ್ಕೊಡ್ತೀನಿ.
ಸೊ ಎನಿವೇ, ಸೊ Thank you, sir. Today you deliver a wonderful talk on fluids. Based on
ಓಕೆ ಆಯ್ತು.
many.
ಯಾಕೆಂದ್ರೆ ಫುಲ್ ಮಾಡಕ್ ಹೋಗ್ಲಿಲ್ಲ, ಯಾಕೆಂದ್ರೆ ಫುಲ್ ಟೈಮ್ ಆಗೋದಿಲ್ಲ. ನೀವು ಹೇಳಿದ್ರಲ್ಲ 1 hour ಒಳಗಡೆ ಅಂತ.
Yes, sir. ಇಲ್ಲಿ ಸರ್ ಏನಾದ್ರು ಟೈಮ್ ಇದ್ರೆ ಇನ್ನೊಂದು ಕ್ಲಾಸ್ ಕೊಡುವಾಗ ನಾನು ಸರ್ ಕೇಳ್ತೀನಿ.
ಓಕೆ ಸರ್, ಆಯ್ತು. ಯಾಕೆಂದ್ರೆ
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ದಿ ಆಪರ್ಚುನಿಟಿ ಗಿವನ್ ಟು ಮೀ. ಥ್ಯಾಂಕ್ ಯು.
ಎಸ್ ಸರ್, ತಮಗೆ ಸಿಕ್ಕಿದಂತ ಒಂದು 50 ನಿಮಿಷದ ಕಾಲಾವಕಾಶದಲ್ಲಿ ತಾವು ಫ್ಲೂಯಿಡ್ಸ್ ಬಗ್ಗೆ ಹಲವಾರು ಮಾಹಿತಿಗಳನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಾ ಸರ್. ಸೊ ನಮ್ಮ KST ಪರವಾಗಿ ಹಾಗೂ ನನ್ನ ವೈಯಕ್ತಿಕವಾಗಿ ಧನ್ಯವಾದಗಳು ಸರ್.
ಓ ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು. ಓಕೆ.
ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿ ಅಧ್ಯಕ್ಷರಾದಂತ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಸೊ ಹಾಗೂ ನಮ್ಮ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜಿಸಿ ನಮಗೆ ಪ್ರತಿದಿನ ಸಲಹೆ ಸೂಚನೆಗಳು ಕೊಡ್ತಾ ಇರತಕ್ಕಂತ ನಮ್ಮ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್.
ಸೊ ನಾನು ಕೂಡ ಇಬ್ಬರಿಗೂ ನನ್ನ ಧನ್ಯವಾದಗಳನ್ನ ತಿಳಿಸ್ತಾ ಇದ್ದೀನಿ, ಪ್ರೊಫೆಸರ್ ರಮೇಶ್ ಮತ್ತೆ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಅವ್ರಿಗೆ. ಓಕೆ, ಅವ್ರು ಇಲ್ಲ ಅಂದ್ರೆ ನಂದು ನಮಸ್ಕಾರನ ತಿಳಿಸಿ ಅವ್ರಿಗೆ. ಓಕೆ ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
ಹಾಜರಾಗಿದ್ದ ಎಲ್ಲಾ ನನ್ನ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ಹಾಗೂ ನನ್ನ ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವಿವೇಕ್ಸ್ ವೃಂದದವರಿಗೂ ಕೂಡ ನನ್ನ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. Thank you once again, sir. Thank you very much.
Oh, thank you, sir. Thank you. Okay.
Please, you don't forget, sir. Please send the 2 descriptive questions.
Okay, then.
Okay, thank you, sir. Thank you.
Okay, sir.